So I guess one of my first questions, I wanted to get any thoughts or experience about how to implement both solutions to test to ensure that the platform works functionally, but then also solutions for availability and reliability of a platform like that. Do you have any thoughts about that?
Yeah. On a higher level, the product looks cool, but one thing that I was missing is what the user experience is like. Why would the users will be coming to the web? But then, yes, first let's answer your question. So when you talk about the high availability, right? So it depends on the targeted users. Are they from different locations?
Yeah, so everyone's online, just everyone can be in a different spot, and they're just on their laptops or on their phones, and they're all connected to the same conversation.
Okay, got it. So see, the availability definitely matters here, and then it is how well you are applying your caching algorithm. That it really matters here, and also the deployment strategies should also be we should definitely provide 100% high availability. Let's say you're moving your code to production, and then there should not be a production down periods or something like that because it's all real time the way I see it. So we can just enable blue-green deployments in that case, so that the traffic can be devoted, split and devoted by means of Route 53, wherein you'll split the traffic whenever. I'm just talking about the production deployment scenario, and then I'll come back to the regular scenario as well. So let's say the best strategy would be split the traffic into some 10% to 90%, and then 10% will be provided for the new server with updated code. If you are using microservices architecture, probably the Lambda that you are serving, the updated version of the Lambda, it will be hitting the 10% of the traffic, and we can have it beta test over there. And then once that is done, it will be allowing, if everything is working fine, then the remaining 90% traffic will be shifting towards that using Route 53 alone again. So otherwise, which we can have a rollback enabled, which is an instantaneous rollback, and then this 10% of traffic also will be reverted back to the previous version. So that's how we usually manage by enabling this blue-green deployment. And yeah, it pretty much depends. Again, if you talk about the high availability, right? So I cannot actually tell you entirely on different components because it all depends. When you talk about the clusters, the database stuff, regarding high availability, right? So you definitely need to, again, it depends on if you are using RDBMS or MPP system or NoSQL database. So there are different concepts of high availability and standards that you need to follow. So
yep, yeah, we're using Postgres, but it's hosted by Google Cloud.
Okay, cool. So Postgres on a Google Cloud. Okay, I do have experience in Postgres hosted on AWS, which means it has to do something with RDS. RDS is a resource of AWS where this Postgres can be hosted. If you are familiar with that, I can explain you on how we achieve high availability over there. Yep. So there is something called read replicas. So what we do is, see, the main concept before we used cloud also, in good old days, there will be a table, and then that table will not be prone to hitting with the traffic at all. We'll be creating a view upon which the view will be served to the traffic. So the same concept here is RDS will have, it will retain a physical table with itself, the main table, and then there will be something called read replicas that are enabled over across the multiple availability zones that was spanned over. Again, it depends on where your traffic is focused merely on. So depending on that, you can enable your read replicas and then make those available in those availability zones so that the traffic will be served from them. So it's like just a view on the table where there'll be exactly reflecting whatever the table is having. Even the updates will be instantaneous. That's about the database terms of high availability that you achieve.
Mm-hmm. Yeah, I'm familiar with this setup. Yeah, I think that makes sense. I was wondering if you had any more thoughts on, let's say we have, let's say we have a bad deploy or something. Let's just say that the platform goes unavailable for some reason, I don't know, maybe we use or we use S3, and S3 becomes unavailable, and either some or all features, or some core feature of the platform goes down because of that. Do you have any thoughts on like how you would deal with that, like kind of in this real time? So like customers running this live conversation, or maybe they don't notice this feature is missing until they get into the live conversation. They start asking questions, and now we have this issue where we didn't notice. Do you have any thoughts about how we could kind of resolve those types of issues, or something's kind of actively happening and while the customer is actually using the platform?
Yeah, that's an interesting question. It's actually a general issue that we come across in most of the setups, I would say, because this engineering stuff, we do it, we establish it, and then we cannot predict everything go ideal, right? So this happens. So what we follow is, I would say, wait for it to happen, because you do not have any choice. Once we take all the precautions, once we make sure all the unit test cases were tested thoroughly and the production code is deployed, but even then, there are certain cases where these things, whatever you might have told now, so they might have, they will definitely occur. So what we can do is, so whenever such scenario happens, let's say a server issue in this case, let's say we're talking about the S3 failure, which we cannot do anything. So what we have to do is, whenever there is the downtime of S3 occurs, so the traffic definitely cannot receive any responses, and then we can just track it out. There are logging tools like we use Datadog. We also use Splunk based on the type of data that you want to log in, and because if you have a huge humongous amount of data and it is widely distributed, randomly distributed, I would say, not relational at all. In that case, if at all needed, we'll be using Splunk because it's too costly when compared to Datadog or Sumo Logic. So otherwise, if you do have just bunch of services, bunch of microservices linked up together to form a single or 2-3 products that make up everything. So in that case, I would say Datadog does the job. So have your alerting system enabled, and then integrate with your messaging networks like Slack, using PagerDuty or whatever the tools, and make sure that the alert system is on red alert. So that's how we start the getting notified, because the whole point is, being a DevOps guy, you do not have to work on the issues, the DevOps pipelines and stuff like that. The ideal expectation is, you just need to wait for something to come up. And then how it should come up, in a sense, you should never miss a thing. That's first step of doing it is alert system, after which everything should be automated as far as you are concerned, and your work should be minimized. So that's how we have to enjoy our life. And then we have to learn and then learn and implement, make sure this so-called damages are not happening again and again.
Sure. Cool. Okay, so that makes sense. There's some ideas around market reliability. So we have this. So I guess I'll just to re-highlight kind of the unique part of our business, which is that, like I said, we have these live conversations that have maybe 500 people or 1,000 people online at the same time and doing the same activity at the same time, right? Mm-hmm.
Yeah.
But we don't have these are like in a lot of our use cases they're actually paid money to be there. So they're being paid like $20 or $30 for the hour or whatever to actually be online during that time. So a conversation with 500 people could cost maybe be $30,000 for our end client. Because we don't like sell these, like these aren't happening 24/7, right? We don't have like 24/7 rolling traffic or anything like that. We have like a scheduled time for the conversation to run, but then when it runs, it's suddenly like everyone joins at the same time, and suddenly you start to see like you don't have critical peak times other than that when the conversations are scheduled. Mm-hmm. And maybe at any given time we'll only have like we can either have one of these conversations running or we could have 10 of them running, but we generally don't have them running like throughout the day very often. So thinking about like kind of so scale is something we've been working on recently a lot, which is just like how many people can we support in a single one of these conversations. Mm-hmm. And in some ways the limiting factor in theory of that is actually our machine learning code, mm-hmm. which is like how much can we actually learn anything useful in this period of time for that many people. Mm-hmm. But on a more practical front, that really isn't the limiting factor yet. Mm-hmm. So I was wondering if you had any ideas about how we'd actually go about testing our app at scale, and both. So both actually like in order to in the idea of like trying to scale it up higher to support more people and more conversations, but then also on the front of ensuring that a change to the code doesn't actually negatively impact the performance of the full stack, right? Maybe a change to our infrastructure or a change to some database query or something like that we don't really notice in our test suite because our test suite doesn't reenact a live conversation with 500 people or 1,000 people concurrently, right?
Yeah.
So do you have any thoughts on how you could go about testing something like that?
Absolutely. So the first thing that hits my brain about the scaling is, again, I'm sorry, I have to speak about AWS terms because I'm not well versed that much in GCP. So cool. So there is auto scaling option, and there are two types of auto scaling that are available for us. And step scaling is one of it, and then normal auto scaling is one of the other categories. So we can tune our servers in such a way that they can be auto scaled according to the traffic that is served. So it's like we do not have to worry about the increase in the traffic as much as when we have the extremes predicted. So it's like in a very extreme case, this is the traffic that I can have. So this is the resource that in a maximum that we want in the worst case. And in the best case, this is the minimum traffic that we have. This is the least resources we'll be using. So if you have these extremes with you, so all scaling is not a problem at all in this cloud era.
Okay. And reporting toward like I said, when we don't actually you don't see this like slow rise in load. You see it immediately when a moderator asks a question. You have this 2-minute window of time. That's when you actually recognize load for the first time. Yes,
there are parameters that you can make use of where to scale up and where to scale down. If your CPU utilization is crossing 60% or 70%, that's where you can scale up your another virtual machine. And then if your CPU utilization is really going down below 30% or 25%, then you can scale down. So it's like you can set a parameter as CPU utilization, traffic is served, and then here are the factors. There are actually 5 or 6 factors that you can choose upon.
Sure, but what I'm saying is like the CPU, for example, you would not it wouldn't scale up fast enough because you would see this load happen as soon as the question was asked, but you would have to scale up within the questions are by the time that you scale up your questions already over. So it's a 2-minute long thing, and you need to be scaled before the 2-minute long thing actually starts. So maybe you could scale up something like more custom, like the schedule of the conversation or something along those lines.
Okay, again, the question is, my doubt is you do not have any idea what the traffic will be before that question is asked, right?
Well, no, we have an idea of what it will be because, like I said, they're scheduled in advance.
So that sounds good, right? We can also schedule the traffic. Schedule our scaling mechanism as regarding. With respect to the traffic that we are expecting, right? So that should not be a problem.
Sure. Cool. And then so that's one thing. So how else can we go about testing? But I guess I'm more interested in the actual. So there's one thing about let's assume we know how to handle the current load, but that we need to ensure that new code changes and new changes don't negatively affect the load that we can handle with given resources. And let's start with there actually.
I'm sorry. Can you repeat the question?
Yeah, so let's say we already know how to manage
predict the load and then scale. Okay.
When we change code or we change infrastructure, that we're not negatively impacting our we're not. Let's say we have some auto scaling factor, and we don't want to negatively impact that factor by changing some code or changing some make sure that basically code doesn't get negatively impact the scaling of the live conversation, but there's no live conversations going on. So for example, you can't just roll out the new code to some users because there probably aren't any users online until maybe 8 p.m. that day, and there's all the users online. Are there any ways you could test scale in a vacuum, where we could ensure that this new code being rolled out doesn't negatively impact scaling, and maybe new code or infrastructure change, whatever, doesn't negatively impact scaling like that?
Yeah, we definitely see the stages through which the code will be hitting the production is not just, we will not just directly go push the code to production, right? So that's never going to happen in a real-time environment. So what we'll do is we'll have to test in our sandbox environment or the testing environment or whatever it is, and then test with the sample traffic, and then once it is good enough, and then once the functional test cases are validated, and then obviously when you did a change, first of all you'll be testing with the boundary conditions, and then unit testing, and then the functional testing, and then only then you'll be pushing from testing to production. So once you are
sample traffic that you're talking about.
Sorry, how do you?
How is the sample traffic that you're talking about using?
So it again, if you want to test across the sample traffic, in the sense, it's related to come entirely when you scale up your resources and you want to make sure that this resource is capable of handling this much of traffic, right? So it's all, when you talk about the traffic, it's all about requests and responses, right? So if you do wish to really know about the capacity of the resources that you're scaling up, if mostly we can just infer this. So this resource can handle this much of traffic. We'll be having a calculation rough in our brain. So, but then if you really do want to know about it in a practical testing environment, so you can just send some sample requests. So when you say that there are 20 users online, it's equivalent to 20 requests and response. So
have you ever done like a case that's sort of like a current environment? Because kind of one of the main, it's harder to send these requests. Like you need to basically send in these requests and replies like the simulated traffic in a super concurrent way. Have you worked with any tools that do anything like that?
The tools that will send the traffic in a concurrent stage, asynchronous.
1,000 users online at the same time doing the same thing, and they send a bunch of requests. You know, they send requests every few seconds, each of them in parallel. And it's kind of like the scaling obviously changes a ton if you have a lot of concurrency versus if you just send them all serially.
See, I worked in a similar setup, but then again, it's not exact same because the concurrency matters, but then we can manage with messaging queues like RabbitMQ, Kafka, Celery, SQS, etc., depending on the use case. But then here, it's a bit tricky here. The mapping should be convenient, and then the request should definitely follow by a response. And then I see that I still did not get clarity of how the response is reacting. It's like, is it a one-on-one mapping, or whenever the request is sent, like let's say 50 people are there, 50 people has said their answers, and then they'll be repeating to the telling the same answers again and again to different questions, right?
So yeah, like if you read a question, they'll all submit their answer, and then they'll all start to see each other's answers. So they'll be like, it's kind of like a little game almost, where you're going to see the real answer these, just choose agree or disagree, or you choose a binary like A over B or something like that.
And then
so like, a window, every participant's going to send about 30 requests or so.
So what are we going to do with this request? We are just going to store them, and then depending on the request, we are not again replying them, right? We end of it, and then we'll be asking the next question, right?
Sorry, say that again.
So it's not a two-way conversation. We'll just ask a question, and then they'll be answering, and then the answer will be stored for our analysis, and then inferring, and then we'll be asking the next question. Is that so?
That's correct. Yeah.
Got it. So in this case, we can just use a messaging queue. Because you'll be definitely getting a bulk messages. So there are plenty of options again. So if your traffic is humongous again, so go for Kafka. But in our case, it's not that. So a simple SQS platform, again, if you're talking about AWS terms, so a simple SQS will be doing the purpose. So I understand the concurrency, but then there'll be when you enable a messaging queue, you can just have the options of delaying the messages and then sending the messages instantaneously, and then you can also replay the messages by using SNS feature. So it all depends on your how you want to manipulate it and what you want to do with those messages. So, but then it's a good practice to have it, and then you can also have kind of a streaming platform for a real-time extraction of all those messages. So.
Sure. Yeah, I think that makes sense. Okay, cool. So moving on a little bit. When it comes to actually working with developers, can you talk about maybe your experience in the process of how you actually go about working with engineering teams? Like any process you put in place on like how to actually prioritize tasks. You know, since we're a startup, we definitely have like more tasks than time sometimes. So how would you go about prioritizing tasks like that? And I guess just start with like how you communicate with how you've worked directly with engineering teams before.
Sure, yes. So what we would do is, it's a flattened platform where there will be a Scrum Master. Again, I worked on agile methodology and pure DevOps platform as well. So let us start. I also worked on waterfall as well, but in this modern world, the recommended setup would be DevOps. So let's talk about that. So when you talk about DevOps, so it's all like the ticketing platform where there will be a Scrum Master prioritizing the task. So a point of contact to make sure something happens on a priority out of the blue. So that is not priority till now, but it is some priority today. So it has to be done. So in that case, we have to prioritize via ticket, wherein the P0 issues should be addressed by the developers or so-called team or whatever the concerned team it is. So that's how we initially approach them, and then a proper follow-up via meetings. Maybe they should be addressed in the stand-up meetings as well. So that's kind of notifying them for the priority. So they'll be parked aside the non-P0 issues, and then they'll be sorting this out. And then the 8 steps of the DevOps process will be inlined for our prioritized tasks.
Gotcha. So I'll give you a little bit of idea about how our team is split up right now. So we have about 20 people total in our engineering and product teams, and we have an R&D team. That's what I manage, which consists of just like our machine learning engineers and stuff like that. Then we have these two product feature teams, and each one consists of a product manager, a designer, and then a QA person and a few engineers.
Okay.
And so that's kind of like how our team is structured now. So it's kind of like figuring out a way to work. And with our DevOps role that we're making this hire for, is like how do they work across engineers? How do they work across not just engineering teams, but also the business requirements? So as we start to grow and sell to more to larger and larger clients, they kind of have different expectations for security practices and infrastructure change management and stuff like that. So do you have any thoughts on how you can stay in communication with both those engineering teams, both those feature teams, and then also identify the problems that they're having, and then kind of prioritize them amongst other business tasks like the security policies and things along those lines as well?
Definitely, Paul. So you see the scenario like this. So whenever there is a setup, so let's say you have a whole infrastructure in your hands, right? You'll not be scaling up with the click of the button in the console. So there will be definitely infrastructure as a core platform that will be handled by the DevOps engineer, like CloudFormation or Terraform or serverless or something like that. So infrastructure as well. Maybe Ansible also does it. So and we also have to handle the configuration management, and we'll have to be on high alert on that, because many instances we'll be seeing that there will be a minor updates in the versions or the modules or the API versions that are going to be changed, and we need to tackle that in real time. And then if you are choosing, it depends on the configuration management tool that you have, again, like Chef or Ansible, you have to push the changes after a proper validation. So we definitely have to be on our heels when it comes to the changes or the enhancements related to the development teams. So how we basically do is, it's like we do have our Slack channels, and then one of the common issues I'll tell you. So there is data engineering team that we maintain in our current setup. So what we would do is, they have a couple of updates all the time that are having to their API keys. So they'll be also having some data engineering, the marketing APIs through which they'll be extracting a lot of data in real time. So the API keys will have this proper expiry. So it's like some 40 to 50 API keys, more than that, of course. So they do have their expiration dates, and once they were done, they'll be freaking out. The DevOps guys, they'll be hitting upon us. So what we do is, we automated that entire cycle of API expiration. So now we do not have to worry about resetting the passwords or API keys, because we know the expiration dates of each and every API key that was available already in the documentation. Then we'll launch a script via Airflow. Airflow is again a scheduler that we use, that we choose to use, built on Python. So we have the freedom to core and schedule whatever the way we wish. So we have scheduled a job for each API to the expiry. So it all depends on the scenarios that you might want to handle. But the bottom line is, we'll have to be there with the developers in the initial phases. But then once everything is done, the core part of it, right? So it can definitely be automated. That's what I would say. I do not find things that are not that cannot be automated and purely dealt manually. So it all depends on how you analyze and how you can orchestrate through automation. So
okay, cool. So I think that's about all the questions that I have. Do you have any questions for me about either like Remesh as a company, our product, our engineering team, technology, whatever you want to ask?
yeah, sure. So I'm curious about the product and the insights of how we are going to make more money out of it, and what is the but that was not a business perspective, but then I would like to know about the DevOps team that is currently present there, and then the setup that you have now.
You want to know about what was the second question? Sorry.
The current DevOps platform that you are having in place, and then the team.
Well, I'll answer your product question first. So yeah, basically our product right now, I think our current revenue is about something like $500,000 a month or something like that. The product, so it's kind of being sold in several different ways right now. So the first one is like I mentioned, that market research use case, and in some ways they're being sold as like individual projects. So for example, we just ran a conversation with 800 people that were all incentivized and paid, and it was an hour long, and I think the total cost to the customer was like $86,000, and our margin on that was about $50,000. Then so that's like we call it like transactional, or like it's just a single one-off. They purchase that one conversation. The same use case that are on like annual contracts where they're purchasing like unlimited software usage. And they still go through us for this. Like we call those participants that are paid, we call that sample cost. And that's kind of one of the biggest problems of our business is like, how do you figure out the hard part about Remesh is always getting people online to participate, right?
Yes.
And so market research, they generally have to just pay them with money or do something like that to incentivize them. Obviously, in use cases like employee engagement, you already have your employees, so you just tell them to show up, and they do. So the employee engagement use case is like a bit more. That is like a bit more sustainable for as far as like like it's easier to sell subscription software to that. The only thing is that our platform's not quite as useful for it, and it's like the value hasn't been shown as being super valuable in that use case. It's been somewhat valuable, but it's just not a huge growing use case for us. So in market research, we're expanding just by making our product is like valuable enough for we're making the revenue that we are now, but there's just a lot of things we can do to make the products fit within workflows of existing market research teams at companies, and that will make it like a lot more repeatable, like make usage a lot more repeatable. Right now, they have to kind of just do a lot of the work to like be able to use Remesh in their system. So that's kind of the next steps for us over the short term. In the long term, I think the successful is to find a way to, instead of like having to essentially pay people to show up and participate, we have to find a way for them to participate because they want to, right? And that may be maybe in market research use cases where it's like about something that they're interested in, like if it's about like I don't know, a video game or something like that they're interested in, they want to talk about new features to add or something like that, they will show up without being paid, just because they want to give their input. But in the use cases, in some of the use cases that we have, like it's just no one wants to talk about those topics unless they're being paid to do it, you know. So I think that's the problem for us to solve. It's like the big change. Otherwise, I mean, maybe the way to solve that isn't even in market research areas, to solve it in other industries or in other potential sales, but that's kind of like the longer term way for us to grow a lot of the business, I think.
Got it.
Does that make sense?
Yes. And there are a couple of ways available in digital marketing field to fetch the traffic, but then what we need to focus on is retaining the traffic to participate in that. Okay.
Yeah.
Cool.
So that's your first question. The second question was our current Devops platform and team. So our whole app is deployed on Kubernetes right now on Google Cloud Platform. So everything infrastructure is code. Like we basically have. There's only one thing that's like. There's only one I think like somewhat of like a quote unquote pet server, which is our Jenkins CI server. And that's like what runs all of our tests and builds, and we push containers from that, and we just deploy containers to Kubernetes, and we upgrade from that as well. So our deployment process right now, we have 3 environments. We have like our dev environment where we deploy. We have like, so in Git we have master branch, we have dev branch, And we always push, we like make pull requests to the dev branch, and all the developers, like that's kind of the dev branch is like the bleeding edge, most up to date thing.
Yeah.
We deploy that to our like dev environment all the time. That's where it gets tested and QA there a little bit.
Mm-hmm.
And that's where you can like our product managers can interact with our most up to date features and everything. And then we have our staging and production environments, and those are both by default running the master branch at all times. And when we go to release code right now, the way we do this is that we basically make a release candidate branch from our dev branch. We deploy it to stage. We do QA there. We have a manual QA process for like our end-to-end tests right now. And then we're working on automating, but right now it's manual. So we make this release candidate branch. We fix any regressions on the release candidate branch, and then when it's ready, we merge it to master and deploy that to prod. That's our kind of system right now. And then as far as the DevOps team goes, we have one DevOps engineer, and she's based in New York, and she's kind of more on the I would say like on the ops side more than the dev side. So she's doing like handling like we're doing penetration testing at the end of this year and stuff like that. So she's handling some of that stuff. But it's just kind of like there's a lot of stuff that our kind of dev team needs to be automated and things that we could improve there, and that's kind of what we're looking for with this role. So
Got it. Cool.
Yeah, does that make sense?
Yes. That
Cool.
does.
Well, if you have any other questions at all, feel free to shoot me an email. My email is just paul@org. And other than that, I think that's all I had. So in that case, I will just come back.
Sure, Paul.
Cool.
Thanks.
All right. Thank you so much. I'll talk to you later.
Yeah, sure. See ya. Bye-bye.
Bye.
Have a good day.